My name is Goll and I'm working for SUSE as a HPC user-space software developer, I think is my job title at the moment. And what I'm doing is kind of integrating all the HPC software that it can be directly used out of the box with SUSE, and because we have the factory first policy, you can also use it on OpenSUSE, which is the free version of our operating system. I will talk today about my Hack Week project. So we have once a year, 1 week time to do whatever we want. It just have to touch something with computer. And I decided to use the TensorFlow I've packaged on Bugzilla data so that I know what tools are still missing on SUSE. Is this package I created really working like expected? So exactly here it's my Hack Week project, and then really see, do we need additional tools or is it all there, and how are they fitting together? That was also the goal for me a bit to find out, do we need some more tools? I found some, I do not mention them in the talk, but there were some small Python libraries missing for tossing around the data, which you have to do in machine learning. And I did this whole thing with TensorFlow because TensorFlow is the tool with the biggest mindshare at the moment. So it's kind of, if you're doing machine learning, most people think this is just TensorFlow. There are also kind of other packages around which you can use, but it's the one where you find the most tutorials and the most things and the most examples. The outline of my talk is I will briefly talk about, or we will talk about, I think this is at the moment the biggest part, about how to install TensorFlow in OpenSUSE, then what Bugzilla is if you don't know it, then what data I get out of, and a bit my results, because it was just 1 week, I did not really get that promising results. There are three different ways on which you can install TensorFlow. You can have it as a system package, you can have it, which means you install it as an RPM through the package manager, you can have it as a container, or you can have it installed it via pip, which is a Python tool, which then downloads TensorFlow from somewhere from the internet. But now I will talk about a system package. It's an RPM, and that means it has direct hardware access, so because it lives really on the system, the dependencies, so all the things it needs, are resolved by the package manager. In our case, that's super, so you just type in super, install TensorFlow, and then it's there, and all the dependencies it really needs. If you do it with the other method, sometimes you are missing out some dependencies, and you have to find out what is missing and what is not missing. Also, in the future, the user can choose. We have now, as soon as it is a distribution, we have a stable version. This means that over the life, you will always get the same version, which means you can reproduce the results, which is, in my eyes, very important. So that's the thing where but you could also kind of download the newest bleeding edge version directly from Factory or from OpenSUSE or from Tumbleweed, which is our rolling release distribution. And the old versions are always available, and you could even rebuild them. So if you want to reproduce the results in 10 years, you can still go to the Open Build service and build it, or even build it for new hardware or for new targets. The disadvantages at the moment are that we are not able to create the system package with GPU support. That's due to licensing issues, but we would need CUDA in the Open Build service. And there are legal reasons why the OpenSUSE project can't do this, but we are working on that. We are trying really to get CUDA in the Open Build service so that we can also have GPU-enabled things there. And the TensorFlow package itself is fragile. What I mean with this, it's kind of the build in the open build service of the package relatively often breaks because it has some kind of dependencies which are not easy to resolve. So the other thing is to just take the Docker container and do a Docker installation. The advantage is an all-in-one solution. You just download the Docker image and then you just attach to the Docker image, and that's most probably it. The thing is, it's not that easy as you think. As I said, you just download one Docker container, but the Docker container has a size of 1 gigabyte or even more, which is kind of, no, that's not a container. That's not as it intended to be. A container should have really a minimal size and not gigabyte. And for example, they're still using Python 2 in the container, which is kind of completely, Python 2 is deprecated next year. It won't get any security updates or something like this. You have the thing that with Docker, the container runs as root and not as your system ID, which means you will run into problems accessing data, especially if you write data. It will be under the root ID or some else ID. There might be other solutions like Podman where you don't run into this problem, but it's too easy to really have root access there. Also the NVIDIA runtime, which means the CUDA runtime, the CUDA libraries bleed in and bleed out of the container, which means you have on both sides, you need to have the exact same versions. And that's also kind of not really portable, because then you really have to see, okay, this is now my base operating system, the container really needs that version. Is NVIDIA still building the packages for that version I'm actually running? That's not a thing you really like, and especially if you think of you really want to run the container for longer or want to work with the container for a longer time, at a given time it will simply break, so that's not that nice. And you could install things in containers, that's always possible, but it's not a nice way, because then you have containers lying around with different versions. The other thing is you can simply do this with pip. Pip is this Python packet manager. You should have, if you do this in a virtual LAN, if you can't, you really do not interact that much with the system, but this is then also the disadvantage a bit, because then, for example, if you use Matplotlib and want to do the plots with the Qt interface, you simply, you actually realize, you don't have a direct access to the hardware with the pip packages. Also the packages which come from pip have not that high quality, they are not always working so good together with the distribution as the distribution packages. Also you need to match the CUDA versions again, which also puts you in some trouble. And you do not have that good version control like you would have with the system packages, which means with Super. Still, for my experiment, then I really used the pip approach, because that was the only really way to get it running on the graphics card, to run it on the GPU, because that was the thing I also wanted to try out, how much faster the GPU is really compared to the host CPU. So the Bugzilla thing. Bugzilla is our open bug database, so every bug someone reports goes into Bugzilla. Which means we have unstructured data at the start, which means we have the bug summary, which is just the title, and then we also have the bug description. And then if the bug is closed or fixed, then we have a really structured data, like then we know in which, because then it's kind of triaged the bug, then we know in which area the bug was. If it was a really high impact bug, the importance of the bug, we knew who resolved it, we knew which packages were fixed, and we also perhaps knew CVE numbers or something else like this. And so my idea was to go in to find out if we could connect the bug summary and bug description as soon as you type it in, and see if we could then interfill this kind of other data. Now, how did I get the data out? The thing is, our Bugzilla, it's old, it's not old in the sense of the software version, but it's old in the sense of it's used, I think, now for more than 20 years. So this means we still have very deprecated structures in there. not all APIs which are now available in newer Bugzilla versions could be exploited. But I found this Python Bugzilla library. There this goes over the web interface, or this has some, there I found out this could really grab the data out. I only use the publicity available bugs, which means I did not really want to get some secrets out. This would not really be now, and then the front end of Bugzilla is really slow. So it took me really a long time to get the bugs out, to get out the training data. Oh, now that's it. The results, I found at least 3,000 bugs, which means, but that meant I had to query the interface for 10,000 of bugs, because just 20% of the bugs are public available. The rest of them are kind of closed, so they are just available for SUSE employees, which are for partners, because they kind of reflecting bugs regarding this. I didn't think that many bugs are closed. I could not really find a proper field which gives the area of a bug, because this could change over time, and categories also change during software releases. That's also not so nice. And also the severity of the bug could change, so I could not really that one. So I really want to interfere. Is it possible from the bug summary and the first bug commit to see the number of the comments, which means how active the bug was, and also the seconds between the first and the last comment, which means how long it really took to fix that bug or to close that bug. And you just need a number of seconds and not days and time. I think it's simply the easiest way to use time is just to count the seconds. Yeah, and at last that's what I got. So that's then the example data I used. It's just now a JSON file with the ID and all this kind of stuff which is describing that bug. Yeah, then if you then really want to interfere from that bug, you have to, that was also the kind I wanted to find out which tools we have. So I found out, okay, we need really keras because, and sklearn, because there we could then process the text in an appropriate manner so that you can fit it into a neural net. So you have to pad the input always have to have the same size, so you have to do padding, you have to do a mapping, and then you also have to split the data into training data and the test sample. So this gave me these other libraries I had to then I had to push into OpenSUSE. Yeah, so this is now just a bit of the data. So this is histogram of the text length. So there are many bugs with the same text length, but there are some bugs which really have a long history and a long description. Also the number of the comments, most don't have just 3 or 4 comments and then it's fixed, but there are some really outliers which take a very long time and very longly discussions about what to do with it. But it's a kind of typical 1 through X distribution, which is kind of normal for, which I would really expect, because from your own perspective, you know this outliers where you really, and at the 100 comment, nobody knows what is really going on. You just drop in another comment. And I also wanted to see, for example, if there's a kind of easy connection between the number of comments. Does this directly reflect how long it takes to fix the bug? And there's no kind of clear correlation here. If there would be clear correlation, you would see a line, and we definitely do not see a line. Yeah, this is then keras based, and I added several layers, optimizers, mean square in the last function in order to train the net, but unfortunately I completely failed. And then it was Friday and the hack week was over, so I still have to improve on that part. Okay. Yeah, the conclusion is I still sure that the TensorFlow system package would have many advantages. I still try to push that forward, and also there are this kind of, I still don't know if it's possible to really find out to get an automatic triage just combined on the first comment in the bug summary. Okay, and that's all. Thank you for your attention.
All right.
Yeah?
So did you do anything for PyTorch?
Yeah. I'm actually trying to push the PyTorch package into open in factory. There's nothing missing at the moment. I have to rename a bit the package name because they have at the moment a wrong structure and still, but it will be there in some time.
All right. Thank you very much, Christian. Let's give him a big hand. Well, you already did that. All right.
Yeah.
Let's go ahead and have a drawing for that.